Cool. So now we are recording. Yeah, and how are things with you all?
I'll give you a tour of the room.
Yeah, it looks like we have a new friendly face in the room.
Hello.
John, there we go.
Okay, John.
Angeline, you want to introduce yourself?
Hi, my name is Angeline. I'm current undergrad at UBC, helping me out with the GTG, the toolkit thing, because I'm kind of interested to do more on it. So, yeah.
Cool. Do you have a specific project that you're working on, or?
Yeah, so I'm actually working with a semantics AI company right now for a summer internship. So what we're doing is hopefully we'll incorporate DOMS program and do some, I'll say the end goal is to do some machine learning on it, but right now we're just hopefully using like the outputs, the polygon outputs to get some reasoning about it. So right now we're just in the process of like getting the right output with the reasonable depths from it. Yeah.
Cool. Well, glad you're here.
Yeah.
And have you met everyone in the room at UBC?
I met Mike at the climbing wall.
Devon today.
Yeah, I met Devon today, Ren today. Yeah, basically everyone else today. So yeah.
Do you know John?
No.
Yeah, I'm John.
Hi, nice to meet you. Yeah.
Joe, do you want to briefly introduce yourself? Say hello.
Yes, sure.
Whoa.
So enthusiastic.
No, it's been a long week. My name's Joe Capriati. I'm down in Golden, Colorado at the Colorado School of Mines. I'm a PhD student, almost finished with Yago Lee. It's been a long week because we had to move buildings again.
Oh, wow.
My background looks a little different this time.
Yeah, no kidding.
Joe, is Yago back?
No, he's still in Brazil.
Oh,
At
okay.
least he was yesterday.
And then before we start, can you give us the background about your shirt?
Oh, my shirt? Iron Man?
And
That's
when was your last Ironman competition?
Not that kind of Iron Man.
Cool.
On that note, Lindsay.
Hi, I'm Lindsay. I'm a postdoc at UC Berkeley. I did my PhD at UBC, and I've now been here for over 6 months at this point, basically since last November. So I'm working with the Jupyter team. I guess if you've been using the toolkit, you've been using Jupyter Notebooks a bit. Yeah, so I'm working with the Jupyter team here on sort of Jupyter in the geosciences is broadly the things that I do. So yeah, and done a lot of work, of course, with SimPEG and the team here. So
She's our deal leader.
Cool. Okay, well, with that, do we want to maybe do just start with like quick updates, or if there's any questions or things people want to raise that we make sure we chat about today? I can start, I guess. I just two quick things. I'm going to be away the next 2 weeks. I might be able to make it next week. I'm flying to Seattle for the Pangeo meeting. My flight lands around 1 p.m., so I might be able to make it at 2. But if somebody else is willing to set up the video recording, if there's going to be enough people around, that would be awesome. I can walk anybody through how to do that, because I can give you the LBL, I can give you access to my Zoom. So I don't know if somebody's willing to champion that.
Yeah, I can probably hook us up. I managed to get in the room without you. Is that because if I just click on that on the Zoom thing? Anyway, yeah, tell me how to do it.
We can walk through it briefly. Anybody can always enter. It's just a question of the recording, and I think I can give you like rights to be sort of the meeting administrator, which means you can hit the record button.
I can boot people out. Sweet.
It's true. Yes, you can. So much power. And then the following week, I definitely won't be able to make it. My parents are in town, so we're playing tourist. The other quick update on my end, I've been working a fair bit in the time domain EM code. Soggy pointed out that there was a slight discrepancy with the B formulation when doing airborne simulations. Just at the very early time, we weren't quite dealing with it properly. So I've gone through actually and like written out all the equations again. And I think that hopefully the result of this will be basically simplifying how we're handling initial conditions. Because that I think is where the error was coming from before. So I'm gonna try and generate a pull request that will go just directly onto the simulation class. Like at this point, I'm sort of like doing all new developments off of there basically. So I'll ping probably Soggy, and if there's anybody else who's interested in diving into the time domain EM code, just let me know and I can make sure you're looped in on that conversation. That's basically it from me. Do you folks at UBC want to take the reins?
Yeah, well, John and I have been working on, John, you want to tell us the awesome news?
You have the preconditioner working.
Oh, excellent.
Yeah. It's running quick and memory's flat. Yeah, it's a great thing.
Yeah, so John and I over the weekend experimented quite a bit on trying to use Paradiso with dask. And then we found something pretty interesting is that you actually can't do both at the same time. There's an issue on the MKL Intel website. If you try to do too many parallelization, you kind of start adding up a little rounding off error. And then we were running the simulation multiple times and getting different results every time. So, but we found a kind of workaround. So we can basically form all the right-hand sides and then compute the J matrix in blocks and then just store those blocks on Zarr one at a time. And since Paradiso is parallelized anyway, we're kind of using all the CPUs. Once it's done, using all the CPUs to store it to disk. And then once it's done, we're kind of bringing it all together into one big J matrix. And yeah, it's pretty awesome. Yeah. Like the memory footprint is stable. We're fully parallelized for the JVEC, JTVEC.
And this is in the...
Again?
Which code is this in?
This is simulation JK right now. It's
no, but this is in the the MT code.
Resistivity. Yeah, resistivity.
Okay.
Yeah. But now that we've figured out the whole AM, I think we can spread it across all the EMs. It's all going to be the same thing, right?
With the issue with Paradiso, so I was successful in running, like at least using dask as a job scheduler, and then running Paradiso from there, and that was okay. I had to be careful with how many threads I let Paradiso access, because you can sort of run into like runaway situations where like one node tries to grab all of the threads, like Paradiso tries to grab all the threads. But what were you running into?
Let's say you delay, it's basically to delay Paradiso solves. And if you try to launch dask on all those delayed functions, it calls Paradiso multiple times. And that kind of, I don't understand the bottom of it, but basically that thread that I put in the Google Doc explains what it is. It's basically just a random access of memory, and then it adds up a bunch of round-off errors. And then you end up with results that are changing every time you run it. So you never get the same result.
Okay. So for then for the DC code, you're just not using the Paradiso solver? Is that?
No, I do use the Paradiso solver, but we just do it. We do it right away. We don't delay that function.
Okay. So that you do the forward solves right away. Do we have? Are there any other like urgent items people want to go over? Or are we okay if we like continue this? Okay. Yeah. Would you mind showing some of the code?
Yeah. So it's under static resistivity simulation. So when we do the fields, right, it computes the field and it stores the factorizations for A.
Yeah.
And then when we ask to get J, we just compute the blocks because you need to do self.amp on each of the receiver for each of the sources.
Yeah.
So instead of delaying that function, we just do it right away. So this is already parallelized on the paradiso. So it's using all the threads, all the processors right away.
Right.
And then once that's done, then we're storing that chunk to a Zarr file. To Zarr. So we're just sending a block of it, and then we do this for each of the blocks of receivers, and at the end we're just putting everything together in one big Zarr. And this is our J matrix.
Cool. And so the thing that didn't work, just to like check my understanding here, is if you had stuck a dask delayed like on that specific step. Okay.
If you do this, that's well, if you do like a definition of this, right, of like, let's say a solve A, and then you put this inside here, this doesn't work.
Okay.
Because now you're dealing the paradiso solve inside dask.
Right.
Yeah.
Okay.
And that one gives us different results every time.
That's scary, but I'm glad you figured that out.
And so John and I tried like, okay, let's try like, other solvers like LU, let's try iterative solvers, but nothing is nearly as fast as paradiso. So that's kind of our workaround.
Okay.
Yeah.
Cool.
So how does this scale up for like was all your testing done with on a single machine? I'm kind of curious how this would scale up to multiple machines, like on a cluster computer.
That's a great question. I'm not sure. I'm not sure how we would do this. I guess we could do another level of parallelization at the source level. We could send this on different machines, right? And then each machine would have their own paradiso solves. That's it. That's my guess.
Yeah, that's cool.
Anyway, the good news is that this works really well right now, and it's pretty easy to implement because all we need to do is to delay some of the sparse matrix operation, and then yeah, cool. Send it to Zarr.
And have you done sort of any even loose like benchmarking of what sort of improvement you get here versus just like the matrix vector product?
That's cool. Sorry, would you say that again, sir?
Oh, I guess like do you have any sort of benchmarking, even if sort of just loose, of like the new implementation versus the previous implementation where we just computed JVec on the fly?
Just JVec on the fly?
Or without storing J, right?
Oh, without storing J, yeah. It wasn't that much quicker, but it's quicker.
Okay.
But we're also forming full J, whereas what I tested it was the new implementation and then just the old one without forming J, and it's faster than without storing it and forming it.
Cool.
And mostly getting access to the preconditioner is massive, right? That like it saves us so many iterations, Gauss-Newton iterations. We can get there a lot faster.
The example that I sent there, it was usually about 8 iterations and solving it in like 3. And it's really good. Results. Visuals are good.
And what preconditioner are you using?
Jacobi.
in the regularization, or where does that come in?
The preconditioner is in the optimization, right?
Oh, okay. Okay.
Yeah.
So the preconditioner is on the CG solver?
Yeah.
Okay, cool.
Well, we just, we overload the HFROX in the optimization, because that's used in all the solvers, in all the optimization class.
With this pull request, would you guys mind making an example where you like explain some of these steps? I mean, or if you have an example started, just where like some of these subtleties come into play, like where the preconditioner is used and stuff like that, so that we can use that as a bit of a reference.
Yeah, I should be able to modify what I have so that you don't have to take those input files and yeah, just put some comments in here and there.
That'd be great. I think that would go a really long ways.
Yeah, we did a cleanup too for the new naming, right? The source list is everywhere, the location naming and all that stuff.
Yeah, I was trying to look for some of those. And then when you pulled that pull request, I was like, oh, there they are.
They're deep.
Yeah, they're deep.
Yeah. You need to do a lot of like line debug one by one. Like, okay.
Excellent. Well, what's your sense on like the state of the pull request? Do you want like I can try and jump in sort of this weekend if that is.
I was gonna add the MT stuff in there, but maybe it's better to just do that as separate PR than just leave this one to the DC.
Yeah, because I mean, at least from the brief example that Dom showed, like this looks like it would be nice to have in there and have people start sort of hitting on it, playing around with it. Yeah, and deal with MT as another, because that's going to be another like fairly major set of changes.
That'll be big, yeah.
I think we just need to update the examples that are connected to DC, right?
Yeah.
Yeah, just to make sure that they all run.
They all run. Yeah. So I built I started one built off of the 2.5 D.
Okay.
So yeah, I've got to start, and I think we were talking about doing this as well. Or maybe merging a few examples. One that I have. Yeah. Yeah, totally doable.
Excellent. Well, this is exciting.
But we will need dask for the tests, though, right? Because I was looking through why they're failing, and it mostly seems it's when it's trying to do anything with dask.
Oh, we need to include it in the requirements. Probably. Yeah, that's probably just
requirements. Or it actually, at this point, if it's in the code base, it should be in the setup.py. And I think that that's totally fine. That it becomes an explicit dependency of SimPEG.
I don't know why it's failing. But we'll look it up. But I guess that's what we need to do before we can. Oh yeah.
No module names Zarr.
Yeah, so we just need to include it in the. Yeah.
Excellent. Are there other folks at UBC who have any updates, things you'd like to chat about? Not so much.
It's not.
Joe, I was wondering, I saw a whole issue thread on discretize, and I saw that you chimed in there. Do you have a couple minutes to maybe just give like a quick update or like what the issue is potentially? It looks like we have some import stuff going on that's causing problems.
Yeah, I mean, I haven't had time to look at it at all. I just kind of looked through the bug report. It was some sort of meta-class conflict. I'm not sure where it's coming from. Peter had said something about matplotlib, but I'm not sure if he tracked it to that at some point that was causing that issue or not, because he was the first person to bring it up. Like it wasn't in the initial bug report anywhere. So, but I mean, we're testing on 3.7, right?
I think so. We should double check.
Yeah.
Because now that I say that, we might not be.
We could also test on Mac as well on Travis if you wanted to.
That's probably worth, we probably shouldn't run the entire test suite, but it would be nice to at least maybe run the base.
Yeah, just to make sure it's importing properly. So
that's a good idea. Okay.
But I haven't had time to delve into it at all.
Yeah, no problem. But thanks for chiming in on the issue, because it looks like it's a new new user potentially, so that's kind of
yeah.
cool.
Joe, I might have to. Did you work on the 2D on the quad tree mesh trying to order UBC? I was trying to use PyVista to plot a 2D quad octree, I guess, a quad tree mesh, and then it's choking on the UBC order. Does that ring a bell?
Yeah, I think the UBC order, I have to look at it, but I think it was just for 3D things. I'm not sure why. So I'm not sure why the PyVista would be using that, because it shouldn't be necessary at all.
It's calling it because it's trying to get the node locations.
Yeah, but
yeah,
I'm not sure why it needs it for that. I'm gonna have to look and see how Bain implemented that to see if it's actually necessary or not for those. Which my initial assumption is that it's not, because it shouldn't be. It's creating a unstructured mesh which has no order to it, so it shouldn't matter.
Okay, I'll ping the snippet to you in Bain then.
Okay.
Okay. In terms of other topics, the one other thing that I was thinking of is with respect to getting people up to speed with SimPEG, especially I'm thinking with respect to like the groundwater project and getting Ren and Doug much more comfortable with like running the DC code, what's going on within SimPEG. I was wondering if like maybe, I don't know, next week or the week after, I know I won't be able to be here, but if like maybe going through a tutorial or walking through a notebook or like having some more targeted tutorial time would be beneficial. I don't know if like timing, Ren and Doug, you can update us on like where you're at, if that makes sense now or in, you know, a month from now, that kind of thing. What's your take on that?
My guess is sometime after about a couple of weeks, like sort of beginning of September would be a bit better time scale.
Okay.
So I feel like the SimPEG examples for DC right now, I have gone meticulously through them, and I don't understand absolutely everything, but I have a better idea.
Excellent.
So I'm not sure if it's absolutely necessary for me, although maybe some kind of novel application could be useful. Yeah, I mean, I definitely have questions. Some parts it's just the documentation is not great, so it would be nice actually.
Okay, well then maybe we can think of something sort of like early September. And even if that is just like a question, like if you sort of bring your list of questions and we work through that, it doesn't necessarily have to be like a, line by line, we're coding through the problem. But if you've got specific questions, that can be, might be nice to have some time set aside for that.
I mean, I've actually got the ball rolling on this. I've got 4 modeling examples for gravity, mag, MDI, DCIP, FEM, TEM, and I got 3 version examples, but they're not written for the new simulation class. So if it's wanting to use the tools that we have right now, the stuff's already developed and put into an example that I can give to anybody. But if we're just holding off a little bit longer for us to start using the simulation class, that's sort of when I was going to make the push to add it to the website. But really, like 80 to 90% of the work on a lot of tutorials is actually done. So if
Excellent.
you learn the tools that we have now, I can just send you examples that I have right now. I think that was one of these. Yeah.
I mean, from my gut reaction to that is that like maybe I think that's like up to users basically, or like if there are requests for specific things, then like let's make sure that it's let's prioritize those and make them live. But then yeah, I sort of agree that like waiting for the simulation is probably not a bad idea. I mean, if they're basically done and ready to go, then feel free to like start the pull request and we'll get them in the repository and then you can refactor them with the simulation. That's also totally fine because if all the work is basically done, then it would be great to get them shared.
So maybe pull your kind of your simulation development branch into the branch that I'm working on, and then rewrite those examples using the simulation class, which I think your examples.
Yeah, I can give you a hand with that because I've done the DC already and started the MT as well.
Okay, no, that's simulation. Yeah, maybe when you come in next Tuesday, I think we could do it.
Yeah.
And then we're just kind of, not having to do something twice. That's kind of labor intensive.
Sure.
These examples definitely need to be reviewed, but at least in terms of understanding the syntax, I think they're pretty useful.
Excellent. Well, and that's actually potentially perfect timing is if we do sort of a big push on examples once the simulation class is stabilized a little bit more. That sort of aligns with when we want to be doing a bit more tutorials and such in sort of September.
Okay, cool.
Cool. Sounds good.
So the tutorials you're doing, are they more the style like right now, which is kind of a big block of code?
No,
Or is it more like
just super
explanation?
It's more like for the forward modeling, you're basically saying maybe I've got some data locations, I've got XYZ positions, or maybe I can create my XYZ positions, and then I've got some file with some topography. And so I've got this, and I'd like to run some forward simulation where maybe I've got like a dike, and I want to see if that explains some anomalies. It's really practical in that sense. And we go through step-by-step, creating your mesh, using the topography to go and find places. You know, how would you have to set up the transmitters, receivers, and make your survey, and how you would image the data. So it really has the feel of a step-by-step process of like a practical workflow.
That sounds great.
Sounds good. We'll see what it is.
Excellent. Cool. Okay. That's basically all that I have. Is there anything else that others have?
I ran those tests on the frequency domain derivatives, and everything seemed to check out and converge to second order. So it must be something that's just how I coded up the MT with the simulation class, that something's just not talking to each other right, or that something's wrong. But yeah, I'll dig into that here now that preconditioners kind of well,
on its way up. Yeah.
But I'd like to start timing.
Well, we should check, and maybe this is something even next week, Devin, when you guys are doing a tour de force on examples, is check just the forward simulation outputs comparing UBC and SimPEG for like I guess like either the L-shaped model or something that has a little bit of complexity. And then I don't know, can the UBC code do sort of arbitrary receiver configurations? Like, can they support the examples that John is thinking through?
You have to go, I think it depends which code. For E3DMT, we have a second generation code where you physically define the electric and magnetic field receivers. There's a second generation E3D code, so frequency domain, and there are a few bugs that are being fixed to finalize a time domain EM where you define the transmitter receiver loops as well. So I think in the end, we'll have all that.
I've started trying to make a similar one, or similar forward simulation as the L-shaped one that you sent me the link to. I just haven't got to the run yet. I just kind of got everything going because I couldn't load in just the mesh model or the meshes and the conductivity, or sorry, in the model files. Yeah, I tried, did it with the new discretize. I pulled the most recent one and it just says something tree doesn't accept this. And that's as far as I got. I didn't dig farther yet. But I've ran around it and made one out of just the code.
Yeah, I mean, you can get the input file, but what the actual input file was to generate that mesh, make something that's like 99% the same thing, and you'll get that.
That's where I am right now. Well, just now I'm just making the model, so I should be able to. Yeah, we can do comparison on that one.
Or you should fire that mesh that you can't load to. You should create an issue because we want to be able to load the mesh.
Okay, good point. Yeah, I did it with the old like not simulation, and it loads in.
Oh,
but
okay.
with the simulation class, it's usable.
But,
yeah, I'll raise an issue. I wasn't sure if it was me or I wanted to make sure.
Well,
yeah,
it worked before.
Yeah,
it worked before and we broke it. Feel free to create.
Yeah, I always think I break things.
Cool.
Short meeting.
All right, sounds good. Well, Dom, I will send you details for Zoom and we can try that out. And I will try to join next week. But if not, I will catch up with everyone in a couple of weeks and watch your videos.
Lindsay, can you stay on for a moment? I want to ask you something just after.
Yeah, for sure, for sure. That sounds good. Cool. Anything else anyone wants to raise before we wrap things up? No? All right. Well, have a good afternoon, everyone. Thanks for taking time to catch up.
Thanks.
Bye, Lindsay.
Bye. Bye, Joe.